Okay. Now, if we know V naught, VF, A, delta S, and delta T, if we know three of these things, we can find the other two. We saw that with the equations before, and we can see that with these diagrams. Okay, for example, if we're given delta S, A, and delta T, well, we have delta S, and we have A, and we have delta T. What can we find? Well, from delta S and delta T, we can find V bar. From A and delta T, we can find delta V. How are we going to now find V naught and VF? Well, if we know delta V and V bar, we can find V naught and VF by this picture. So, what's the picture? V bar is halfway between V naught and VF. From V naught to VF is our delta V, and it follows, if you think about it a little bit, that V bar is equidistant here. So if the distance from here to here represents delta V, or the displacement from here to here represents delta V, then the displacement from here to here is half delta V, so that VF is V bar plus half of delta V. And similarly, V naught is on the other side of V bar. You're going to have to subtract half of delta V to get V naught. So V naught is V bar minus 1/2 delta V. So everything works, and we don't have to resort to a lot of algebra and equations. And one advantage to reasoning things out this way is not so we can see the diagram, so the diagram can guide our thinking, and we can think about what everything means. If we know the displacement and the time interval, how's displacement time interval related? Well, your displacement is equal to the average velocity multiplied by your time interval. Okay, so there's information, and we understand that, so we can think through. We can actually calculate the average velocity and see how the numbers relate. And so forth. Every step of the reasoning has a meaning, and the meaning is understood in terms of just three quantities. One that you find from the other two. Forces you to think about how everything is related, and then to get into this somewhat complex system of thought, and not only get the right answer, but understand where the right answer came from. Now there's one case that we can't do, so address that in a minute. Okay, I'll also mention 3 of these 5, okay? You can always get a solution, but you can't always reason out the solution. You can do it for this, you can't do it for this, and I'm going to talk about that. I'll also talk, well, I'm just going to say it now, that if there are 5 things and you need to know 3 of them in order to solve the situation, well, there are 10 possible combinations of the 3 things you could have. Like, you know, there's this, this, and this, 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 okay? You could list them. There are 10 possible combinations. Of those 10, there are only 2 that you can't do by direct reasoning with triangles, essentially, or the equivalent of reasoning with triangles, just basically reasoning with these 2 definitions. And we'll talk about that in a minute.